Hello viewers, welcome to my channel. I am Hasham. This is the last and final video on two-way ANOVA problem. Previous videos I have completed so many problems on one-way ANOVA and two-way ANOVA. Hope my regular viewers have already watched all the videos, got a good command on the problems of one-way and two-way ANOVA. But before that, you must know the meaning of analysis of variance. So I have uploaded one video on the meaning, on theory, explanation of theory regarding analysis of variance. It's a statistical technique where we compare three or more than three sample means. Whether all the samples have same means or all the samples have the populations coming from the populations having the same means, that's what we want to find out. And this statistical technique is very widely used in research techniques. Particularly this analysis of variance was started from agriculture. In agriculture it was required to be find out whether the fertilizer, different types of fertilizers are applied on different plots to find out whether the yield is same from different fertilizers or not. But later on, the application has changed. Now every area, many areas we apply this statistical technique apart from agriculture. So two types of problems, one-way ANOVA and two-way ANOVA, where we are comparing only one factor at a time. Only one factor we want to compare, one-way ANOVA. Simple example, suppose if we want to find out the average yield from 5 different types of fertilizers. Only fertilizers we are studying, it is one-way ANOVA. But sometimes it is asking you to find out the differences between fertilizers and different plots. Because yield does not depend only on fertilizer. The yield also depends on the fertility of the soil, on the plot of land. So we want to find out whether there is significant difference in the plots of land and also in between the agriculture. We apply two-way ANOVA. Like that. Now, one problem is finally left, that is 7th problem. All other problems I have completed. So 5th problem, 6th problem and 7th problem. These 3 problems we are doing for two-way ANOVA. Remaining all problems were one-way ANOVA. Out of these 3, 5th and 6th already I have completed in the previous videos. Now last and final problem, 7th one. Before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. So always keep ready the problem. Now take a screenshot of the solution of this 7th problem, then I'll explain. Come on, see the 7th one. 4 technicians analyzed 3 samples. Technicians are 4, A, B, C, D. And they have studied 3 samples. The samples are X, Y, Z. Technicians are given in columns and samples are given in rows. So 3 samples and 4 technicians. So 4 technicians analyzed 3 samples each for the moisture content in the sample. In each sample, how much is the moisture content? For example, A technician have found 9 in X, 12 in Y and 9 in Z. These are the moisture content found by technician Mr. A on 3 samples X, Y, Z. Similarly, B is another technician. He has also measured the content of moisture. Then in X, Y and Z, he found 12, 11, 10. 10, 15, 12, that is C. D, 11, 12, 14. Now analyze the data and comment. Use 5% level of significance. It is not saying that we have to apply ANOVA analysis of variance. It is not saying whether we have to apply one-way or two-way. Nothing is given. Simply it is asking you analyze the data and comment. We want to compare. When it is asking you to analyze, it means we want to compare the moisture content found by the 4 technicians, and also we want to find out the moisture content between 3 samples X, Y, Z. So By seeing the problem, we come to the conclusion that it is a problem of ANOVA because we are comparing 3 or more than 3 samples. First point. Second point, it is not specifically asking you to find out only technicians. So that's why we want to find out the difference between technicians and between samples. That's why I'm going to start two-way ANOVA. In that way, I'll analyze. Now, first of all, we can use the same values or coding method. The values given in the problem are 9, 12, 9. That is for A technician. B technician 12, 11, 10. C 10, 15, 12. D 11, 12, 14. If you closely observe this data, all the values are very near to 10. Some values are just below 10 and some values are just above 10. So instead of taking the actual data, we can use coding method. So in examination, it depends on the student whether he can use the actual data or he can use the coding method. The ultimate F ratio will be same. What is the advantage in using coding method? The values will become small. When values become small, it is easier to square. It is easier to make all calculations. Our time will get reduced. So I suggest you to adopt coding method instead of directly using all the values. Ultimate answer will be same. Your time will be reduced. But before that, before making this table in examination, you must write a note. The note is for the sake of simplifying the calculations. For simplifying the calculations, I am using coding method. Subtracting a constant from all the values. What is a constant? An average constant. By seeing just a roughly average is 10 because some values are below 10, some values are above 10. It is easier to deduct 10 from all the values, right? Now, here calculations for two-way ANOVA samples. Samples are X, Y, Z given in the problem. I have denoted by the name R1, R2, R3 for our convenience. R stands for rows. Row 1, row 2, row 3. Columns. In columns, we are given technicians A, B, C, D. So I have given the name C1, C2, C3, C4. Column 1, column 2, column 3, column 4. Right? Now data. First of all, A technician. What are the values of A technician? 9. 9 minus 10. You will get minus 1. Secondly, 12. 12 minus 10. 2. Then again 9 minus 10. Minus 1. First A over. Now come to B. 12. 12 minus 10. 2. Then 11 minus 10. 1. 10 minus 10. 0. B over. Now C. 10 minus 10. 0. 15 minus 10. 5. 12 minus 10. 2. C completed. Then D. 11 minus 10. 1. 12 minus 10. 2. 14 minus 10. 4. Now see here, the original values are 9, 12, 9. All these values are bigger values. Now I have made a small values easily. Without using calculator, we can be able to get the totals. Here, minus 1 plus 2 minus 1. So it will become 0. The column total 0. Here 2 plus 1, 3. 5 plus 2, 7. 4 plus 2 plus 1, 7. So without using calculator, we got it. Otherwise, we would have to use the calculator. Secondly, minus 1 plus 2 plus 1. It is 2. 2 plus 1 plus 5 plus 2, 10. Here row is 5. Now, we can cross-check our calculations. Whether our calculations are right or not. The column total and row total should be equal. T. Column total. If you take 2 plus 10 plus 5, you will get 17. Row total 0 plus 3 plus 7 plus 7. You will get 17. If you get the column total and row total same 17, that means your calculations are right. We have completed all the calculations. Now we'll proceed. First, correction factor, CF. T whole square by N. T is 17. 17 whole square divided by N. N stands for number of items in all the samples. So 3 rows and 4 columns. So totally you can see 12 items are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. N is equal to 12. It comes to 24.08. This is the correction factor. Now, first of all, total sum of squares of all the items in all the samples. Total sum of squares. We have to square all the values, add up and deduct the correction factor, minus correction factor. So here -1 square plus 2 square plus -1 square plus 2 square plus 1 square plus 0 square plus 0 square plus 5 square plus 2 square plus 1 square plus 2 square plus 4 square minus correction factor. Correction factor is 24.08. So you will get the answer 36.92. This is the SST. Total sum of squares of all the samples values. Now, sum of squares between samples, columns. Samples we have in columns and also in rows. So samples in columns are SSC. So SSC is equal to summation C1 whole square by N1 plus summation C2 whole square by N2 plus summation C cube whole square by N3 plus summation C4 whole square by N4. 4 columns are there. C1, C2, C3, C4. Square it, divide by N1, N2, N3, N4. N1 means how many items are there in each column. In each column we are having 3 items. Every column 3 items. So N1 3, N2 3, N3 3, N4 3. Right? Square. 0 square by 3 is 0 only. 3 square. 3 square means 3 3 is a 9. 9 by 3 is 3. 7 square 49. 49 by 3 16.33. 16.3 minus CF 24. So 11.58 is the SSC. Sum of squares between columns. Now sum of squares between rows, SSR. This we require only when we make two-way ANOVA. For one-way ANOVA we don't require this SSR. What is the formula? Summation R whole square by N1 plus summation R whole square by N2 plus summation R whole square, summation R3 whole square by N3 minus CF. 3 rows we have, R1, R2, R3. 2 whole square by, how many items are there in the row? In the row we have 4 items. 1, 2, 3, 4. Each row we have 4 items. So N1 4, N2 4, N3 4. So 2 whole square by 4, 10 whole square by 4, 5 whole square by 4 minus CF 24.08. So 2 2s are 4 divided by 4, 1, 10 whole square 100, 100 by 4 25, 5 square 25, 25 by 4 6.25 minus 24.08, SSR 8.17. Now easily we will find out the sum of squares within the samples. That is called error. Sum of squares within samples SSE. That is equal to SST minus SSC minus SSR. So here 36.92 minus 11.58 minus 8.17, you will get 17.17. That is SSC. All calculations completed. Now we'll make the ANOVA table to find out the computed value of F for columns and also for rows. Because we are having two-way ANOVA, we have to give the conclusion on 2 things, on columns and also on rows. In columns we have technicians, we have to give the comment regarding technicians, and we have to give the comment regarding samples. Now two-way ANOVA, same columns, every problem we are making the same table. 5 columns are there: source of variation, sum of squares, degree of freedom, mean squares and variance ratio, F ratio. So sum of squares between columns, SSC, how much we got? 11.58. Degree of freedom, C minus 1. Columns, how many columns? 4 columns are there. 4 minus 1, 3. MSC, mean sum of squares in columns. So SSC by degree of freedom, 11.58 by 3, 3.86. One item over, one row over. Second row, between rows, SSR. How much is SSR? 8.17. And degree of freedom, R minus 1. How many rows? 3. 3 minus 1, 2. MSR, mean squares of rows. SSR divided by degree of freedom. 8.17 by 2, 4.085 MSR. Lastly, within samples, error, SSE. How much SSE we got? 17.17. And the degree of freedom is C minus 1 into R minus 1. So C minus 1 is 3, R minus 1 is 2. So 3 into 2, 6. That's all. Now MSE is equal to SSE divided by degree of freedom. 7.17 divided by 6, we get 2.86 over. Now easily we can find out the F ratio for columns and F ratio for rows. F ratio for columns, MSC divided by MSE. How much is MSC? 3.86. How much is MSE? 2.86. So 3.86 by 2.86 is 1.35 is the computed value of F for columns for technicians. Similarly, FR, F ratio, computed value of F for rows. MSR divided by MSE. How much is MSR here? 4.085. MSE 2.86. You'll get 1.43. That's it. The purpose of making this table is to find out F, computed value of F for columns and computed value of F for rows. That's it. Now we can follow the steps. The first step, null hypothesis. So we will frame the null hypothesis for columns and also for rows. So two null hypotheses, two alternative hypotheses. First null hypothesis, columns. In columns we have technicians. There is no significant difference in moisture content found by the four technicians. Found by the four technicians A, B, C, D. The mean moisture content is same for all the technicians. No significant difference. Then rows. How many rows? 3 rows are there. Same. No significant difference in moisture content found in the 3 samples X, Y and Z. No significant difference. Alternative hypothesis, opposite. Whatever we have written in null, opposite will take in alternative. Columns. There is significant difference in the moisture content found by the 4 technicians. That is the alternative hypothesis for columns. For rows, there is significant difference in the mean moisture content found in the 3 samples. 3 samples. That's all. So we have framed the null and alternative hypothesis. Now level of significance 0.05 given in the problem. If it is not given, we would have assumed. But here it is given. The degree of freedom for columns. Here you have to see for columns what is the degree of freedom. MSC, how much is the column? 3. MSC numerator. For numerator degree of freedom is 3. For denominator degree of freedom is 6. Because denominator MSC. MSE can have degree of freedom 6. So here V1 is equal to 3, V2 is equal to 6. For columns. For rows, this is the rule. MSR, what is the degree of freedom? 2. MSE, what is the degree of freedom? 6. So V1 is equal to 2, V2 is equal to 6 for rows. So two different degree of freedom for columns and rows. Now we find out the critical region, the table value. I have provided a PDF of this table in the link under my description. Take a printout and keep it ready. In examination also you can carry this table, F table. Without this F table we cannot give the conclusion. Now F table 5%. On the top you can see 5%. So first of all for columns. For columns we have V1 is equal to 3, V2 is equal to 2. Now in columns, degree of freedom for numerator is given here. V1. So V1 is 3. So under 3 against 6. Under 3 against 6 you will find 4.76. 4.76 in the table. So I have taken 4.76. In rows, for rows V1 is equal to 2, V2 is equal to 6. V1 is equal to 2, column 2 and row 6. Column 2, row 6 you will find 5.14. So I have taken 5.14. These are the critical values. So if you draw a diagram, normal curve, the curve would be like this. 4.76, 5.14, this shaded area is the rejection region and unshaded area is the acceptance region. Now we want to compare the computed value with the critical value. What is the computed value of columns 1.35? What is the critical value of columns 4.76? That means below 4.76 acceptance region, our 1.35 is less. 1.35 is less than 4.76, so it falls in acceptance region. Null hypothesis accepted for columns. So for columns, what is the null hypothesis? The mean moisture content is same among all the technicians. So first conclusion, no significant difference in the moisture content found by the 4 technicians. First comment. Second comment is regarding rows. The computed value of F for rows 1.43. The critical value of F for rows is 5.14. Again, you can find 1.43 is less than 5.14. It falls in acceptance region. That means the null hypothesis is accepted for rows. Here what you have written null hypothesis, the mean moisture content found in the 3 samples are same. No significant difference in the moisture content found in the 3 samples. That's what I have written here. So ultimately, the null hypothesis are accepted. There is no significant difference in mean moisture content between different technicians. And there is no significant difference in mean moisture content between different samples. That's it. This is the end of problem number 7. So totally 10 problems I have solved on ANOVA. Among these 10, 3 are two-way ANOVA and remaining 7 are one-way ANOVA. So if you want the perfect knowledge, watch all the videos. Don't skip in between. If you join in between, you may not be able to understand. Keep a rhythm of watching one video with another video. So if you are satisfied with my lecture, give a like to the video. Share my channel in your group, in your friend circle, so that more students can watch the video and enhance the knowledge. Give your comment on this video. Where are you from? And lastly, don't forget to subscribe my channel. Inshallah, we'll continue the next topic of your statistics for management in the next video. And one more point, I want to make it clear that I have started a new channel by name Hans Accounting Institute. The link of the second channel I have given in the description. Visit that channel also. That channel particularly I have prepared for IGCSE students. Those who are pursuing Cambridge or Edexcel Pearson education. For them it is particularly important. But for everyone, it is very much helpful to gain the knowledge, to get a lot of command on accounts, on business studies, on economics. So visit that channel, subscribe my second channel too. Inshallah, we'll continue a new topic in this statistics for management in the next video.